molecular and empirical formula. So we define the empirical formula as the smallest whole number ratio of elements in a compound. Smallest whole number ratio of elements in a compound. So for an ionic compound, you always just get the empirical formula because ionic compounds don't form molecules, okay? For molecular compounds, sometimes molecules are really big, okay? So they will have multiple repeats, if you like, of the empirical formula. So a molecular formula is the formula of the molecule as a whole, okay? Formula of the molecule as a whole. They can sometimes be written in a few different ways because sometimes they're written using parentheses and repeating units to sort of tell you something about the structure. That's the structural formula. Or sometimes they're written in more of an ionic compound style where you just list the elements in order and how many of each of them there are. Okay, so to answer this kind of question, we're asked to group them together if they've got the same empirical formula. So we need to understand how to write the molecular formula and then work out what the empirical formula is from the molecular formula. So I'm going to just kind of scroll this along a bit so you can see more questions. Okay, so we've got 4 different molecules here. So the convention then is what's known as Hill notation, okay, which is you write carbon first because obviously carbon's the most important in the whole wide world, apparently, then hydrogen, and then everything else in alphabetical order, okay? And then you're just going to group them together and use a subscript to say how many of each you have, okay? So we're going to start with carbons for this one. This is where we see how well I can actually count today. So carbon 4, C, subscript 4, hydrogen 1, 2, 3, 4, hydrogen 4, and then oxygen 2. That is my molecular formula. Molecular formula. Now, can I make that any simpler? So you've got to look if you can divide that by any integer to get a smallest whole number ratio. So I can't divide by 4 because 2 is too small, but I can divide that whole thing by 2. So my empirical formula then, if I can type empirical, is going to be 4 divided by 2 is 2. So C2, H2, O. Where's my carbon gone? There you are. So that is my smallest whole number ratio in that molecule. So then what we're going to do is we're going to rinse and repeat for the next molecule. Okay, so molecule B. Okay, so what's our molecular formula? How many carbons and hydrogens and oxygens have we got? Right, so carbon, we've got 1, 2, 3, 4, 5. Did I get them all? 1, 2, 3, 4, 5 years. Okay, hydrogen, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hopefully I got those right. And then oxygen, we got 1, 2, 3, 4, 5. Okay, so that can be simplified. Divide through by 5 is going to be CH2O. Okay. Okay, so then compound C, what do we have? Start with counting carbons to get our molecular formula. We've got 1, 2, 3, 4, C4, H, 1, 2, 3, 4, 5, 6, 7, 8. I hope I'm doing this right. Oxygen 2. So 1, 2, 3, 4, 5, 6, okay. So that is divisible by 2. So C2, H4, O. Okay, again, these have all got different empirical formulas. That's nice. And then compound D. What have we got for our molecular formula? Oh, hello. So we've got 2 carbons, so C2. We've got 2 hydrogens, H2O. So this would be an example where our molecular formula and our empirical formula are the same, right? Because there's nothing that we can divide that by because we've only got 1 oxygen, right? So it's going to be the same. Do any of these have the same empirical formulas? They do, right? So I can see that this guy and this guy have the same ratio of carbon to hydrogen to oxygen. So I think it gets you to like put them into groups. So this could be group 1 and this could be group 1 because they have the same empirical formula, even though they're different molecules with different molecular formulas. And then B and C are different to each other again. So we're going to get that group 2 and a group 3. Okay, so that is one way to ask this question. I believe that there is another way. They just ask you what they are. Yes, so just write the molecular formula and empirical formula for this one. So start with the molecular formula first, because we're just looking at the actual molecule. Okay, so 1, 2, 3, 4, 5 carbons, C5, and then H, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think there's 10 H's. And then oxygens, 1, 2, 3, 4, 5, oh, 5. So empirical formula, divide through by 5 will be CH2O. Okay, so just remember the difference between empirical formula and molecular formula. I find most students know how to do this question. They just forget the definition of molecular versus empirical. So however you can best remember that, whatever works for you will work. Okay.